Hello students, myself Pradeep Kumar Patel, TGT Mathematics from JNB Gosala Sambalpur. Today we will discuss about some application of trigonometry. Before that, let us discuss what is trigonometry. Trigonometry is a branch of mathematics that studies triangle and the relation between their side and the angle between these sides. For this, we are also taking the right angle triangle ACB for finding the trigonometric ratio. Okay. Before that, in this chapter, we will be studying about some way in which trigonometry is used in the life around us. Trigonometry is one of the most ancient subjects studied by scholars all over the world. Now let us see some real life application of trigonometry. Trigonometry is interesting and has many useful applications in the field of astronomy, geography, etc. One of the useful application of trigonometry is to calculate the height of a tower or a peak or the distance of a ship sailing in the sea. We do not need to measure scales. Surveyors have used trigonometry for centuries. One such large surveying project of the 19th century was the Great Trigonometric Survey of British India, for which the two largest ever theodolites were built. During the survey in 1852, the highest mountain in the world was discovered from a distance of over 160 km. The peak was observed from 6 different stations. In 1856, this peak was named after Sir George Everest, who has commissioned and first used the giant theodolites. The theodolites are now on display in the Museum of Survey of India in Dehradun. And this is the image of the theodolites kept in Dehradun. Again, we are discussing, just recall the pre-knowledge. We have already learned in previous chapter trigonometric ratio. So I am taking here the right angle triangle ABC, right angle at B, right angle at B. And here the hypotenuse AC is denoted by H, partner side BC is denoted by P, and adjacent side this base is AB is denoted by P. So using these three sides, we have already learned, that is about your angle. Let this angle is A. So taking this angle, we are finding the trigonometric ratio. Sin A equal to P by H, that is opposite side by hypotenuse. Cos A equal to B by H, the adjacent side of the angle by hypotenuse. Similarly, tan A equal to P by B, cot A equal to B by P, sec A equal to H by B, and cosec A equal to H by P. Again, another terms are there, trigonometric ratio of some specific angles that we are going to use. This is the table for some specific angle of trigonometric: 0 degree, 30 degree, 45 degree, 60 degree, 90 degree. And all the trigonometric value: sin A, cos A, tan A, cot A, sec A, and cosec A. These are the value of all the specific angles. And using this table, we are going to solve some problems in this chapter. The height or length of object or the distance between the two distant objects can be determined with the help of trigonometric concept, and that is known as the height and distance. Okay. Before we are going to solve the problem, we will discuss some terminology. The first one is the horizontal line. The line drawn parallel to earth surface is called horizontal line. Take the figure here. This is the figure. Now observe in the figure, this man or this one person is observing the object, and the line that is parallel to the eye of observer to the base, this dotted line is known as the horizontal line. Okay, this line is known as horizontal line. Now another term, line of sights. What is line of sights? A line of sights means the line of sight is the line drawn from the eye of an observer to the point in the object viewed by the observer. Here the figure, same person is observing the kite, and the line of sight is the line drawn from the eye of observer, means this line, the line joining the eye of observer to object. This line is known as the line of sight here, and this is your horizontal line. Take another term, angle of elevation. Angle of elevation means, yes, the angle of elevation of an object viewed is the angle formed by the line of sight with the horizontal when object viewed is above the horizontal level. That is the case when we raise our head to look at the object. Mark the figure. When this person is observing the object, the head of this person must be upward for observing the object, because the object is above the horizontal line. Okay, so this angle, the angle between the horizontal line and the line of sight, is here known as angle of elevation. Take another one example. Here in this figure, the line AC drawn from the eye of the student to the top of the minar is called the line of sight. This AC, okay, this is line of sight. The student is looking at the top of the minar. Thus, the angle BAC so formed by the line of sight with the horizontal is called the angle of elevation of the top of minar from the eye of the students. So here this angle is line of sight, and this is the horizontal line. The angle between this horizontal line and line of sight is here angle of elevation. Next is angle of depression. Angle of depression is here marked using this figure. That is, the angle of depression of an object viewed is the angle formed by the line of sight with the horizontal when object viewed is below the horizontal level. That is, in case when we lower our head to look at the object. So mark the picture here. This person is observing the person which is standing on the floor, okay, a road. That means the person is observing this one, means he has to lower the head to look at down level. Then the angle between this horizontal line and the line of sight is here known as angle of depression. Okay. So this is all about some term for solving the problem related to your height and distance. Consider another situation here, that is, the girl sitting on the balcony is looking down to object which is on the ground. This girl is looking the object which is on the ground, okay, and she is on balcony. So this is the horizontal line. This one is the line of sight, and the angle between this horizontal line and line of sight is here angle of depression. Here the line of sight is below the horizontal level. The angle so far by the line of sight with the horizontal is called angle of depression. I am repeating again both the definition, angle of elevation and angle of depression. Mark, an angle of elevation is the angle formed by a horizontal line and a line of sight to a point above the line. In this diagram, angle 1 is angle of elevation from the tower T to plane P. So this is the figure. Mark, from this tower, man is observing the plane. So the line of sight is this line. This is the line of sight, and this is the horizontal line. So the angle between this line and the line of sight is here angle 1, and that angle 1 is angle of elevation. Next is an angle of depression is the angle formed by a horizontal line and a line of sight to a point below the line. Angle 2 is angle of depression from the plane to the tower. This angle 2 mark from if a person is observing from the plane to the tower, then what happened? This line is horizontal line and this is the line of sights because the man sitting on plane is observing the tower. So the line joining the eye of observer to the object, that is known as line of sight. So this is line of sight and this is your horizontal line. So angle 2 is here angle of depression. So these are the examples of angle of elevation and angle of depression. Using these terms, we'll now solve some problem related to your height and distance. Before that, just we'll discuss about how to use the clinometer for finding the angle of elevation. Mark here, this is a tree. For measuring the height of this tree from a point, this point, okay, from this point, how to measure the angle of elevation for observing the top of the tree. Okay, from this point, how to measure the angle of elevation to the top of the tree. Mark, one person is observing by using that clinometer. This is the clinometer and he is observing using this clinometer to the top of the tree, and the angle is here measuring that using this one, that is here angle is 40 degree. So like this you can use the angle of elevation for use the clinometer for measuring the angle of elevation. Now we'll solve some problem related to your height and distance. First, take one example. The angle of elevation of the tower from a point on the ground which is 30 meter away from the foot of the tower is 30 degree. Find the height of the tower. Okay. For this, we have to draw the diagram. But here, mark this is the tower and a man is observing from the point, that angle is 30 degree. Okay, and here this is the height of the tower and distance between the foot and the point is here given, that is 30 meters. Okay, so leveling that diagram we are getting like this in the form of right angle triangle. This is the height of the tower and this is the point C. From the point C, you observe the top of tower and the angle of elevation is given here 30 degree. And distance between the foot of tower and point is here 30 meter. Clear? For solving this, let the height of the tower be AB and point be C. Distance of the point C from the foot of tower is 30 meter. This is given 30 meter. Hence BC is here 30 meter. So angle of elevation that is given 30 degree. So angle ACB equal to 30 degree. Now again in right triangle, using right angle triangle ABC, tan 30 equal to the opposite side AB by BC. Opposite side AB by BC. And tan 30 is, you know that from specific angle value table, tan 30 is 1 by root 3 and AB by BC is given here 30. AB is not given, so write AB. Then by cross multiplication you will get root 3 AB equal to 30. So AB equal to 30 by root 3 and multiply both sides root 3 for rationalize the denominator. 30 root 3 by 3, that equal to 10 root 3. So therefore the height of the tower is 10 root 3 meter. Like this we will solve the problem of height and distance. This is one example. Take another one. The height of wall is 10 meter and the angle of elevation of the top of wall from a fixed point is 45 degree. Find the distance of foot of the wall from fixed point. So for solving this, we have to draw the figure first. Understanding the question first, try to understand, then draw the figure. This is the figure, level figure mark. A, B is the height of wall and C is a point. Okay. Then here the height of wall is given 10 meter. That is the lead height of the wall is AB, that equal to 10 meter. Distance between the foot of wall and fixed point C equal to BC, that is the distance. So let that is x meter. In right angle triangle, using this right angle triangle ABC, 1045, this angle of elevation is given 45 degree. So 1045 equal to opposite side AB by BC. And from table we can write 1045 equal to 1 and AB is given here 10 meter by BC is x. So on multiplication you will get x equal to 10 meter, and that is the, yes, what is that? The distance from the foot of wall to point. Next, come to another problem. Two pillars of equal heights stand on either side of a roadway which is 180 meter wide. At a point on the roadway between the two pillars, the angle of top of the pillars are 30 degree and 45 degree. Find the height of pillar and position of the point. Okay, this is a question. Two pillars are there, both are equal heights on either side of roadway. On either side of roadway, which is 180 meters wide. In between the road, the both sides there are pillar and distance is 180 meters. So draw the figure. This is the figure of this problem. There are two pillars AB and CD are here, two pillars. Okay, AB and CD be the two pillars of the equal height as meters. Then let P be the point on the position in between the both pillar such that angle APB equal to 45 degree and CPD equal to 30 degree. Let PD is T meters. Okay, from P to D is suppose T meter, then BP must be 100 minus T because total BD is 180. So if this one is T, then BP must be 100 minus T meters. So in triangle APD, right triangle, 1045 equal to opposite side AB by BP. That is, using the table, 1045 is 1 and AB is here H and BP is 180 minus T. So by cross multiplication, you can write H equal to 180 minus T. Let that is equation 1. H is equal to 180 minus T. Again using this same figure, now take the another right triangle. In triangle CPD 1030 equal to this 1030 equal to opposite side CD by CD by PD, and the value of 1030 is here 1 by root 3. CD is given H and T is taken here T. By cross multiplication you will get T is equal to H root 3. Okay, like substituting the value of h from 1, फर्स्ट इक्वेशन में हम जो निकाले थे उसी वैल्यू को यहाँ सब्स्टिट्यूट करेंगे. So the h becomes a t becomes, yes, in place of h you can write 180 minus t and root 3 is there. Now simplify this. T is equal to 180 root 3 minus t root 3. So by taking this t root 3 to left hand side, you'll get t plus t root 3 equal to 180 root 3. So t by taking the common from these two terms, t is common, 1 plus root 3 is there. So this equal to 180 root 3. Now what is t? T equal to 180 root 3 by 1 plus root 3. But we have to rationalize this fraction to get the answer. That means we have to multiply in numerator and denominator by 1 minus root 3 and 1 minus root 3. So we'll get 180 root 3 whole into 1 minus root 3 by minus 2 using a plus b into a minus b, that is a square minus b square. So 1 minus 3, that equal to minus 2. Then this value is 93 minus 2 root 3. Okay, 3 minus root 3. So substitute the value of root 3, that is 1.73. Then 3 minus 1.73 is 1.27. So multiply 90 with 1.27, we'll get 114.3 meters. That is the value of T. Next, what we have to find out? We have to find out the value of H. Okay. Then how to find? Using the equation 1, H is equal to 180 minus T. So substitute the value of T here, 180 minus 114.3, that is H is equal to 65.7 meters. So hence the height of the pillar is 65.7 meters and the position of the point is 114.3 meters from D. Okay. Take another example. The angle of depression of two ships from the top of a lighthouse are 45 degree and 30 degree on the side of the lighthouse. If the ships are 200 meter apart, find the height of the lighthouse. So this is the question. Using this question, you have to draw the figure. Mark. This is the lighthouse AB, and here AB represents the lighthouse of the height as meter, and CD be the two ship 200 meter apart with angle of depression 45 degree and 30 degree respectively. That is mark here. One is 30 degree, another is 45 degree. And C and D are the position of two ships. In between the two ships, the distance is 200 meter. Okay. Now let BC be x meter. From B to C is x meter. Then BD is how much? BD must be x plus 200 meters. And here the angle of depression is given, that is 30 degree and 45 degree. So ACB angle is 45 degree here, and this angle is same as this one. So angle ADB is here 30 degree. Now using the triangle ABC triangle, you can write 1045 equal to AB by BC, and here 1045 equal to 1. AB by BC means AB is H, BC is X. So H is equal to X. Let that is equation 1. Here H is equal to X. Both are equal. In triangle ABD again, 1030 equal to AB by BD, 1030 equal to AB by BD, and the value of 1030 is 1 by root 3, that equal to H by 200 plus X. H by 200 plus X. By cross multiplication, you will get H root 3 equal to 200 plus X. That implies H root 3 equal to 200 plus, in place of X you can write H because of X equal to H. So this is H. Then taking this H to left hand side, we will get H into root 3 minus 1, that equal to 200. So H is equal to 200 by root 3 minus 1. Then rationalize this, you will get 200 whole into root 3 plus 1 whole by 2, that is 100 whole into root 3 plus 1, that is equal to 273.97 meter. Hence the height of the lighthouse is 273.97 meter. This is your answer. Okay. Take another one, another example. The angle of elevation of the top of building from the foot of the tower is 30 degree, and the angle of elevation of the top of the tower from the foot of the building is 60 degree. If the tower is 50 meter high, find the height of building. So this is the figure. AB is the building. Let building be AB and tower be CD. Given height of the tower is 50, tower का height दिया गया 50 meter, and hence CD is here 50 meter. Angle of elevation of top of building from the foot of tower is 30 degree. ये 30 degree है. Hence, ACB is 30 degree. Okay. So angle of elevation at the top of the tower from the foot of building is 60 degree. So angle DBC is 60 degree. Now using the same figure, this is the level diagram. AB is building and CD is the tower. So here we need to find the height of building AB. AB का हमको height निकालना है. Since building and the tower are perpendicular to ground, then angle ABC is 90 degree and angle DCB is also 90 degree. In a right angle triangle DBC, yes, tan 60 equal to opposite side DC by BC, and tan 60 is a root 3, that equal to DC is 50 and BC is unknown. So you can write that BC equal to 50 by root 3 by cross multiplication. We will get BC is 50 by root 3 meter. Next, again in right triangle ABC, tan 30, you can take the value tan 30 equal to AB by BC, opposite side by adjacent side, and root 30 is here 1 by root 3. AB is here given, not given, and BC is given 50 root 3. So by cross multiplication, 1 by root 3 is AB root 3 by 50. Again by cross multiplication, 3AB equal to 50. That means AB equal to 50 by 3, that is 16 field 2 by 3 meters. That is the height of building. Okay, this is the last one. Take another one. A straight highway leads to the foot of a tower. A man standing at the top of the tower observes a car at an angle of depression of 30 degree, which is approaching the foot of the tower with a uniform speed. 6 seconds later, the angle of depression of the car is found to be 60 degree. Find the time taken by the car to reach the foot of tower from the point. Okay, using this question, you can draw a figure. First of all, mark this figure. This is the tower, and this is the position of the ship, first position. And from the tower, a man is observing the ship at an angle of, yes, the first one is 30 degrees angle of depression, and after 6 seconds the ship moving towards the foot of the tower. This is the point, second position. Okay, mark here. The man and the tower height is let AD, A and D. Given that a man sees the car first time at an angle of depression 30 degree, so angle PAB here, PAB equal to 30 degree. This is the car position, first position. After 6 seconds, the car moves from this point to this point. So after 6 seconds, man sees the car at an angle of depression 60 degree. That means the angle PAC here, PAC is 60 degree. Okay, so this is the diagram, level diagram. Okay, exactly same. So this angle is, if this is 30 degree, angle ABC is also 30 degree. If the second depression is 60 degree, then this angle is also 60 degree here. PAB equal to ABD, that is 30 degree, and PAC equal to ACD, that is equal to 60 degree. And taking this figure, are solving to find, yes, time taken to reach the foot of tower. In right angle triangle ABD, tan 30 equal to AD by BD, and here tan 30 is 1 by root 3, and AD by BD. So BD equal to, by cross multiply, BD equal to, you can get root 3 AD. Let that is equation 1. In right triangle angle ACD, yes, tan 60 equal to AD by CD, opposite side by adjacent side, and tan 60 is here root 3 AD by CD, so AD equal to root 3 CD. That is equation 2. AD equal to root 3 CD. Substituting the value of AD in equation 1, we get AD का वैल्यू हम जब यहाँ सब्स्टिट्यूट करेंगे इक्वेशन 1 में, देन क्या होगा, BD इक्वल टू रूट 3 इंटू रूट 3 CD, सो दैट इज 3 CD. BD इज इक्वल टू 3 CD, लेट दैट इज इक्वेशन 3. BD इज 3 CD, CD का 3 गुना है. So BD can be written as BC plus CD here using the figure, and here BD is 3 CD, BC becomes BC and CD. So 2CD, that means transfer this CD to left hand side. 2CD equal to BC and CD equal to half BC. Here we observe this CD is half of BC. CD is half of BC. So according to question, in 6 seconds, car moves from point B to C. Then, but CD is half of BC. CD is half of BC. Then the time taken by the car to cover the distance from C to D is 6 by 2. That equal to 3 seconds. So therefore, time taken by the car to reach the foot of the tower from the point is 3 seconds. Okay. This is your homework. Question number 1. From top of 10 meters tall building, the angle depression of a moving car which moves with uniform speed is changing from 30 degree to 60 degree after 3 minutes. Find the speed of the car. If the distance of a person from a tower is 100 meter and the angle subtended by the top of the tower with the ground is 30 degree, what is the height of the tower in meters? Clear? Thanks to all for listening me. This is the end of class.